Okay. Now, our next problem, question 10. 4 to the power of x minus 2 to the power of x divided by 6 to the power of x minus 3 to the power of x is equal to 2. We're getting pretty complex here, but trust me, this is going to be solved in a very beautiful way. So, what do you think we should do? Firstly, 4. We already know we did this like the last 3 problems. That is the same as 2 to the power of 2x. Now we have 2 of the same terms. We don't need to substitute here to see that we can factor this out. We can factor 2x out of here, making this just 1. Can we factor 2x out of here? Yes, we can. Because 2 to the power of 2x, remember, multiplication is just repeated addition. 2 to the power of x plus x. And if we were to take a 2x out of this, we would be left with just another 2x. So the top of the function can be written as 2 to the power of x times 2 to the power of x minus 1. Now what? Now what can we do? Now we could brute force our way through this. We could start multiplying, going like crazy. But think, let's see. Is it possible to convert this bottom portion right here into something that perhaps looks like this? Let's assume that this equation right here can be factored in the same manner this is, and that we can end up with something like this. Let's see. I'm going to try and factor out a 3x. Now if we take a 3x, 3 to the x, out of this, this is going to be left with 1. Just going to put this here preemptively. Can we take a 3x out of this? Let's write it over here. 6 to the x divided by 3 to the x. Is this possible? Can we divide 2 numbers being raised to the x power without having to do any manipulation? Yes. Yes, we can. We did it a couple questions ago. We rewrote this as 6 over 3 to the power of x. And 6 over 3? Don't play with me. That is 2. So 6 to the x divided by 3 to the x, that is 2 to the x. There's our simplified equation. And now we can cancel that and cancel that. And so our new equation, 2 to the x over 3 to the x is equal to 2. And now we will do the same as we did here. That is just 2 over 3 to the power of x. And now we have changed that whole mess into this in a way where we can turn this into a logarithm. Log base 2 over 3. Remember, this is what we're bringing down. 2 over 3 of, this is our argument, 2 is equal to x. Plug it into your calculator. That answer is negative 1.71. Yeah. Boom. Very, very, very beautiful answer. Okay. This is our 11th problem. There's one more challenge problem after this one. Let's go. So, question 11, 3 divided by 3 to the x minus 3 to the negative x equals 8 over 4. 8 over 4, that is 2. But I don't like when our exponent is in the denominator like this. I like it on top. So what I'm going to do, I'm going to cross multiply. We're going to make this just cross multiply. 8 times 3 to the x minus 3 to the negative x is equal to 12. And then from there, we will divide again. We can divide by 8, divide by 8, and then that, well, is just 12 over 8, divide by 4, 3, over 2. And then this is just gone. All right. Cool. But now what? Now what do we do? Well, I think our next step is that we can start simplifying a bit. Recall, a negative exponent, that is just the reciprocal. So this is just 3. 1 over 3 to the x. But now what? Is it possible that we can factor a 3x out of this? Or no. Is it possible that we can get this all in one fraction? 3 to the x on its own is the same as 3 to the x over 1. So, if I were to multiply the top and the bottom of this new fraction, 3 to the x, well, that would be 3 to the 2x over 3 to the x. And now we can combine this into one fraction. We can make this 3 to the 2x minus 1 over 3 to the x is equal to 3 over 2. We have another fraction here. I think we can cross multiply again. We're just gonna do it like that. Equation, I'm just gonna move over here. This is just going to be, just draw that, 2 times 3 to the 2x minus 2 is equal to 3 times 3 to the x. Well, if you don't see it already, I see it. I think the next step is that we bring this over here. We just subtract this side by we subtract this side by 3 times 3 to the x, put it over here. Let me do that real quick. Minus 3 to the 3x is equal to oh yeah, minus 2. Now we have solved a problem like this before. 3 to the 2x is equal to 3 to the x to the 2. Let's make a substitution. Let, I used y a lot, let z equal 3 to the x. Now, 2 to the z squared minus 3z minus 2. Rainbow method. 2 times negative 2 is negative 4 minus 3. What multiplies to negative 4 adds to negative 3? That is negative 4 and 1. So, let's do it. Keep factoring. 2z squared minus 4z plus 1z minus 2. Factor 2z out of that, and we get z minus 2 for our first one. Now remember, we write the same thing down here. What can we take out of this to make it like that? Nothing, just 1. Just 1. And so now, we have our answers. Z minus 2 times 2z plus 1. Can you see that? Okay, yeah. Z is equal to 2 and negative 1 over 2. And now we can redo our substitution. Let's do it. Instead of z, we put it back in. 3 to the x equals negative 1 over half. That was our solution. Is this possible? No. We went through this once before. A regular number, not negative, to the power of x will never be negative. Never. So this, not true. That is a false solution. 3 to the x is equal to 2. Now that we can do. That we can do. Log base 3 of 2 is equal to x. Now that, plug that into your calculator, and you will get, where can I write this to make it bombastic? Is there space? I put this right here. X equals, what was it again? 0.6309. And that is true. So yeah, it looked very ugly, but we worked with it and we got to something very pretty like this. And that is our answer. Only one more. The next one looks very simple, but it's actually I actually didn't solve it. I didn't solve it mathematically. I solved it doing something else. So yeah, not photo math, I promise. But let's go. Let's go. It went something like this. I saw it online. Challenge question. 5 to the power of x is equal to 3 to the power of x plus 16. Can you even read that? That is an ugly 5. I will redo that 5. Try it. Try and solve it. I tried to solve it. I tried to brute force it. But I guess it was just a little bit difficult. But then I saw something. 16. That is 4 squared. Now we have some more exponents to play with. But now what? What's the next step? To be honest with you, I don't know. Because I solved this doing something different. I solved this because this equation looks very similar to me. If you have taken a geometry class or a trigonometry class, you have been forced to use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. And in that class, you would have been known that there are some triangles where the side lengths, you can recognize them, and you will know what the other ones are, always, for right triangles. If we were to have focus. We know them. 3, 4, 5. That is one example. The 3, 4, 5 triangle, x is equal to 2. Wow, this marker is dying. You can't even see that. X is equal to 2. Because 3 squared plus 4 squared is equal to 5 squared by the Pythagorean theorem. This equation, if this was any multiple of each other, if we just multiply them by 2, it would still be x equals 2. If this was 10x equals 6x plus 8x, what is that? This is also x equals 2. So yeah, not very well executed, right? I didn't brute force my way through this, used logs and stuff, but it was cool. So yeah, that was 12 questions, exponents, super fun stuff. Am I right? I had a lot of fun coming up with most of the questions. A lot of them I found online and just tweaked a little bit. But yeah, very fun. If there are any questions you would like answered, you could put them in the comments. Other than that, thank you for staying and listening to me yapping this whole time. And I hope this video helped you understand exponents maybe just a little bit better, or you found other ways to solve exponential problems. So yeah, thank you. Thank you for watching.